Okay, so you want to own a cement factory. You picture a quarry cut into the earth behind the plant, conveyor belts carrying stone toward a kiln, white silos rising above the road, and a line of bulk trucks leaving all day, with a product every city eventually needs. Roads need it. Bridges need it. Warehouses, apartment blocks, hospitals, factories, water systems, all of them need it. Cement does not depend on fashion. It does not expire because people change their taste. You make something basic, heavy, and essential, and every new construction project in your region sends another order toward your gate. That is the picture. Now imagine the first morning after you own the place. The kiln is already hot. The quarry crew is already moving rock. The control room is already watching temperatures, pressures, and material flow. Trucks are already arriving, and before you have made a single decision, the plant has already committed you to fuel, electricity, maintenance, technical staff, environmental monitoring, spare parts, and a quarry that has to keep producing the right stone for years. Then someone shows you two numbers: more than $600 million to modernize one established cement plant in Indiana, $2.1 billion paid for a Texas materials business centered on another cement plant. Those numbers should not make sense yet. Cement itself had an average mill value in the United States of roughly $160 per metric ton in 2025. So how does a powder worth hundreds of dollars per ton justify machinery and transactions worth hundreds of millions or billions? And why can one cement company sell more cement than its own kilns produce? That is the part you have to understand before the factory starts looking like a money machine. First, cement is not concrete. The gray material being poured into a foundation is concrete. Cement is the fine binding powder inside it. A ready-mixed concrete producer combines cement with water and enormous amounts of sand, gravel, or crushed stone, loads the mixture into a rotating truck, and sends it to a job site before it hardens. That distinction changes who pays you. Most of your product is not going into small bags for homeowners. In the United States, roughly 70 to 75% of cement sales go to ready-mixed concrete producers. Your customer is usually another industrial operator with silos, trucks, dispatchers, and contractors waiting for a pour. And not every facility with cement silos owns the same business. An integrated cement plant begins with raw material and makes clinker, the hard intermediate product created inside the kiln. A grinding plant buys clinker made somewhere else and turns it into finished cement. A terminal may manufacture nothing. It receives cement or clinker by ship, barge, rail, or truck, stores it, and sends it back out into the local market. From the road, all three may look like industrial sites filled with silos and conveyors. Financially, they are completely different. The integrated plant gives you control over clinker. It also gives you the most expensive equipment, the most intense heat, the largest maintenance burden, and the deepest exposure to fuel, emissions, and quarry permits. A grinding plant avoids the kiln but depends on somebody else to supply clinker. A terminal avoids most manufacturing risk but depends on transport and outside supply. In practice, you might own shares in a larger company, control a plant through a joint venture, or buy an operating business that owns several sites. But the economics are easiest to see if you imagine controlling one integrated plant directly. So when you say you want to own a cement factory, the serious version of that sentence means you want the integrated plant. You want the quarry, the kiln, the grinding system, the storage, and the loadout. You also want the obligations attached to every one of them. Look at the quarry first. Limestone is blasted, broken, loaded, and carried to a crusher. But a mountain of limestone is not automatically a useful cement reserve. The chemistry has to work. The deposit has to be recoverable. The permits have to allow extraction. The rock has to be close enough to the plant that moving it does not destroy the economics before production even begins. Eagle Materials estimates that the limestone reserves and resources it owns or leases near its plants can support each plant at current capacity for at least 25 years. That is one company's estimate, not an industry minimum, but it shows the time horizon. You are not buying enough stone for a busy season. You are trying to justify a factory whose equipment may need decades of raw material to earn back the capital placed around it. Then the stone enters the plant. It is crushed and blended with smaller amounts of corrective material. It is ground into a fine raw feed. That feed moves through a tower of preheaters and toward a long rotary kiln lined with heat-resistant material. Inside, the temperature reaches roughly 1,450 degrees Celsius. The limestone changes chemically and releases carbon dioxide. The material combines into small hard nodules called clinker. When clinker leaves the kiln, it is glowing hot. It passes through a cooler, moves into storage, and later enters a finish mill where it is ground with gypsum, limestone, or other permitted materials. Only then do you have the fine powder that can be loaded into silos and sold as cement. That process looks continuous because it is supposed to be continuous. Material keeps moving, fans keep pulling gas, mills keep grinding, conveyors keep carrying abrasive rock and powder. Dust control equipment keeps collecting what cannot be allowed to escape. The kiln shell keeps turning on rollers while the lining inside protects the steel from heat that would otherwise destroy it, and the lining wears out. So do the bearings, fans, crushers, conveyors, mills, coolers, and every other component being asked to survive heat, dust, vibration, and abrasion. A cement plant does not wait for something to break and then casually call a repair company. It schedules outages. Crews enter the silent equipment, inspect it, remove worn material, replace parts, and try to finish before the plant loses too many production days. Picture that outage from the owner's side. The most expensive machine on the property is stopped. Skilled workers and contractors are being paid, replacement material is being installed. Customers still expect supply. If there is not enough finished cement in storage, the plant may need outside product, a terminal, or another factory in the company's network to cover the gap. This is why owning the kiln is valuable. It is also why owning the kiln is dangerous. Heidelberg Materials' modernization and expansion in Mitchell, Indiana, makes the capital scale visible. The company announced an investment of more than $600 million. Construction began in 2019. The new kiln produced its first clinker in 2023. The completed plant was described as having roughly 2.4 million tons of annual cement capacity, more than triple the previous capacity. More than $600 million, several years of construction, and an existing location already tied to the cement business. That is not a universal price for every plant. It is a specific modernization and expansion. A smaller plant may cost less. A greenfield project may require a different amount. An older factory may sell cheaply and then demand enormous spending after the purchase. But Mitchell shows what modern capacity can require before the first new ton begins paying back the investment. Now put yourself back in the control room. The new line is running. Clinker is moving. Silos are filling. The plant can produce millions of tons. The obvious question is how much of that turns into money. In 2025, the United States produced an estimated 84 million metric tons of Portland, blended, and masonry cement. Estimated shipments were around 100 million metric tons, with an estimated shipment value of roughly $17 billion. The average mill unit value was about $160 per metric ton. That sounds enormous at the national level. It tells you almost nothing about whether your plant is healthy. Mill value is not profit. Shipment volume is not profit. A busy truck lane is not profit. A full production schedule is not profit. Your revenue begins with tons sold. Bulk cement moves into ready-mix plants, concrete product factories, and contractor supply chains. Some product moves in bags. Some owners sell specialty blends. Some sell clinker. A vertically integrated owner may send cement into company-owned ready-mix operations and earn again later when concrete reaches the job site. But every ton carries a cost history behind it. Rock was extracted. Equipment moved it. Fuel heated it. Electricity ground it. Workers watched it. Maintenance kept the line available. Freight carried it toward the customer. The factory makes money only if the selling price leaves enough after all of that. This is where the plant can fool you. Imagine your first strong season. Construction is active. The dispatch office is busy. Trucks queue beneath the loadout. Daily volume rises. Revenue rises with it. The entire site feels healthy because everything is moving. Then the financial report arrives. Eagle Materials' cement segment offers a real version of that moment. In its fiscal year ending in 2026, cement sales volume, including its share of a joint venture, reached roughly 7.471 million short tons. The average net sales price was about $155.18 per short ton, net of freight. Operating margin was roughly $43.94 per short ton. It was a profitable cement business. Its cement volume rose by about 8%. Revenue rose by about 8%. Operating earnings rose by only about 3%. And operating margin per ton fell by roughly 5%, from $46.22 to $43.94. The trucks were busier. The business earned more total operating profit. Each ton left less operating margin than it had the year before. Higher purchased raw material costs and higher fixed costs absorbed part of the gain, although lower maintenance and energy costs helped. The exact mix is company-specific. The lesson is not, More tons can produce more earnings while making each ton less protective. That matters because the weaker ton is the one that has to absorb the next outage, the next freight increase, the next soft market, and the next capital project. A plant can look stronger from the road while becoming more exposed underneath. Capacity creates the same illusion. Nameplate capacity tells you what the equipment was designed to produce. It does not tell you whether the kiln is available, whether customers need the output, whether the plant can reach those customers economically, or whether the owner has to discount cement just to keep the machinery busy. A factory can have millions of tons of capacity and still be in the wrong place. And this is where the story stops being about heat and machinery and starts becoming about a map. Cement is heavy relative to its selling price. Put it on a truck and send it farther away, and transportation begins eating the value of the load. Public company filings have described ordinary truck markets of roughly 150 miles in some cases. Although that is an illustration, not a universal boundary. Some cement travels farther, rail extends the reach, barges extend it, ships and coastal terminals can move product across much larger distances, but every route has a cost. Draw a circle around your factory. Inside that circle are ready-mix plants, concrete product manufacturers, contractors, cities, highways, and every project that might buy your output. Outside it are customers you may technically be able to reach but not profitably serve. That circle protects you. A distant producer may make cement cheaply and still lose the advantage paying to bring it into your market. Now watch the same circle close around you. A new city cannot be moved closer to your quarry. A weak construction market cannot be replaced by wishing for demand in another state. The kiln cannot follow population growth. If most of your market requires trucking and fuel becomes more expensive, your reach can shrink. If a port terminal opens nearby and receives imported cement efficiently, competition can arrive from across an ocean, even when the next domestic kiln is hundreds of miles away. The weight is what keeps some competitors out. The weight is also what keeps you in. In 2025, the United States imported roughly 23 million metric tons of hydraulic cement for consumption, and net import reliance was estimated at about 21% of apparent consumption. That does not mean every inland plant faces the same foreign competition. Freight still matters, but near an efficient marine terminal, the competitor does not need a quarry in the next county. It may have a kiln on another continent and a ship already moving toward your market. Picture the contrast. Your kiln is burning fuel, your maintenance crew is protecting equipment worth hundreds of millions, and a coastal terminal is unloading finished material made somewhere else. The terminal does not carry your quarry risk or your clinker kiln. It carries storage, handling, transport, and supply risk instead. In the right location, that lighter structure can become a serious competitor to the integrated plant that looks far more impressive from the highway. Now look at one of the strangest numbers in the entire business. In fiscal 2026, Eagle Materials reported cement production of roughly 6.9 million short tons and net cement sales of roughly 7.5 million short tons. It sold more cement than it produced. The reason was primarily imports moving through terminals in Houston and Stockton. The company's sales system was not limited to material coming from its own kilns. Terminals brought additional supply into markets where the company could sell it. That changes the meaning of the factory. A quarry feeds the kiln creates clinker. The grinding system creates finished cement, but a terminal can keep customers supplied while a kiln is down, supplement output when local demand exceeds production, or bring material into a market where building another kiln would make no sense. Rail, ports, barges, and storage can change which customers the company can reach. Ready-mix operations can create dependable outlets for the powder. The visible factory is only the hottest part of the system. The real economic position is the permitted quarry, the production line, the storage, the transport routes, the terminals, and the customers close enough to buy the output without freight consuming the margin. That is what you are actually trying to own, a regional supply network built around a very expensive kiln. Now the $2.1 billion transaction from the beginning makes sense. In late 2023, CRH agreed to acquire a Texas materials portfolio, and the purchase was completed in early 2024. The package included a cement plant with roughly 2.1 million tons of annual capacity. If that were all, the price would tell you almost nothing. The package also included a network of terminals along the eastern Texas Gulf Coast, 20 ready-mixed concrete plants, and access to the Austin and San Antonio construction markets. It was expected to generate approximately $170 million of earnings before interest, taxes, depreciation, and amortization on a pro forma basis. The buyer did not receive one isolated kiln, and hope trucks would appear. The plant could manufacture cement. The terminals could receive and redistribute material. The ready-mix plants could turn that cement into concrete. The growing metropolitan markets could provide projects. Each piece made the others more useful. That is why two factories with similar-looking equipment can have completely different values. One may sit beside decades of permitted stone, reach growing cities, load railcars, use terminals, and sell into a dependable customer network. Another may have an impressive kiln but limited reserves, expensive trucking, weak local demand, old equipment, and no practical way to reach a stronger market. The kiln can be nearly identical. The ownership experience is not. And now the emotional part begins, because the network only feels powerful while enough material is moving through it. Say your local construction market weakens, it does not disappear. Orders simply arrive more slowly. One ready-mix customer delays a project, another cuts weekly volume. Winter weather shortens the pouring season in part of your market. The silos stay full longer. Dispatch becomes quieter. The plant responds by reducing production. Fuel use may fall. Some variable costs fall with output. But the factory does not become half a factory because demand fell by half. The technical staff is still required. Environmental monitoring continues. Security remains. Insurance remains. Debt service remains if the purchase or modernization was financed. The quarry and site still carry obligations. Critical equipment still needs inspection. Refractory does not become new because sales slowed. A maintenance outage may still be approaching on the calendar. Now fewer saleable tons are carrying costs that did not disappear. Cost per ton rises. At first, the problem can be hidden. The plant lowers price to keep volume moving. Trucks continue leaving. Revenue still arrives. From outside the fence, the business remains alive. Inside, the choice is narrow. Delay maintenance and short-term cash looks better, but the chance of a forced outage grows. Complete the maintenance and cash leaves, while demand is already weak. Idle the kiln and some operating cost stops, but customers may move to another supplier. Skilled employees may leave, and restarting a long idled line is not the same as turning on a household appliance. This is the structural risk. Cement demand can remain strong nationally while your plant struggles locally. Society can need the product while your particular kiln becomes difficult to justify. The factory cannot escape its market. Sometimes the site does not disappear when the kiln loses its economic purpose. The hottest and most expensive part may shut down while the grinding equipment, silos, rail connection, port access, or distribution function remains useful. A former production site can become a grinding operation or a terminal. Trucks may still pass through the gate. Cement may still leave the property. The business can survive in a different form after the original manufacturing logic has failed. That is a difficult ownership moment because it separates the value of the location from the value of the kiln. The owner may still control storage, transport access, customers, and a useful industrial site. But the machine that once defined the property may have become the least defensible part of it. That does not mean the owner is helpless. The strongest cement businesses adapt both the network and the product. During the first 9 months of 2025, blended cement represented roughly 63% of United States cement shipments. Most of those blended shipments were Portland limestone cement. The important detail is not the label, it is what happens to clinker. A ton of finished cement does not always require the same amount of clinker. Portland limestone cement allows a higher permitted proportion of finely ground limestone than traditional Portland cement. That can reduce the amount of energy-intensive clinker needed for each ton of finished cement, depending on the product, the plant, the available ingredients, and customer requirements. For an owner, that can change throughput, energy exposure, and emissions intensity. But it is not a trick where the factory adds cheap rock forever and sells the same thing. Product standards limit the formulation. Performance matters. Grinding matters. Ingredient supply matters. Customers have to accept and use the product. And even a more efficient fuel system cannot remove the entire emissions problem, because much of it comes from the limestone itself. The United States Department of Energy estimates that roughly 58% of direct cement production carbon dioxide emissions come from calcination, the chemical conversion of limestone. Roughly 42% comes from energy use. Change the fuel and you address part of the problem. You do not change the chemistry of the rock. That creates another separation between plants. A modern line may use energy more efficiently, handle a broader fuel mix, control the process more precisely, and manufacture lower clinker products consistently. An older plant may need major capital at exactly the moment lower utilization has weakened its ability to pay for it. The factory you own today has to finance the factory it needs to become tomorrow. So does owning a cement factory work? In the strong version, you control high-quality permitted limestone with decades of life. The kiln is modern enough to run efficiently and reliably. The plant serves a region with durable infrastructure, residential, and commercial demand. Trucks can reach important customers without consuming the margin, while rail, water, or terminals extend the market beyond that first circle. Ready-mix and concrete product customers buy consistently. The plant runs at high utilization without giving away the product, just to stay busy. Maintenance happens before failure decides the schedule. The owner can make blended products, manage fuel exposure, meet environmental obligations, and still retain enough cash for the next upgrade. That can be an exceptionally durable regional business. In the weak version, the acquisition price looks cheap because the problems are expensive. The kiln is old, the easiest reserves are declining, difficult, or limited by permits. Most customers require long truck routes, local construction weakens, a terminal introduces imported supply, utilization falls, so fixed cost per ton rises. The owner discounts cement to protect volume, delays maintenance to protect cash, and then discovers that neither the market nor the machinery cares about the purchase price that once looked like a bargain. The plant may still be operating. That is what makes the weak version dangerous. A silent factory looks distressed. A busy factory can hide distress much longer. At the beginning, you pictured limestone entering one side, cement leaving the other, and money collecting somewhere in between. But the kiln is not a machine you buy once and simply wait beside. It is a permanent claim on the quarry, the power supply, the maintenance schedule, the transport map, and the construction economy surrounding it. Owning a cement factory works when all of those pieces keep the kiln economically useful. What you are really buying is not the powder, it is the right place to make it,